All right, we've already looked at how to find percentage concentration. So in the previous video, we looked at mass over mass, mass over volume, volume over volume percentage. But in this video, we're going to try and look at how to express very, very small concentrations. And we do this using two possible formulas. The first one on the left side, you'll see parts per million. And this is where you have your mass of your solute divided by the mass of the solution times 10 to the power of 6. And that whatever that number is, you have that unit is ppm. So if I find 3 is my final answer, it's 3 ppm. Now parts per billion is mass over solute divided by mass over solution times 10 to the power of 9. Now in this case, you would have your answer and you use the unit of ppb, parts per billion. So what does this look like in terms of an actual question? So, for example, symptoms of mercury poisoning become apparent after a person has accumulated more than 0.02 grams of mercury in the body. If the person weighs 60 kilograms, express this amount as ppm. Now, if you take a look at the formula, you'll notice that there's no units for the mass of solution or the mass of solute for either one of these formulas. And that's because you just need them to be consistent. So if you're using a certain unit of mass in the solute, you just have to make sure that it's got to be consistent for the solution as well. So I'm given grams in my question. So I'm going to try and keep that consistent for both the solute and the solution. So part A says if the person weighs 60 kilograms, express this amount as ppm. So my general formula for ppm is ppm is equal to grams of solute. So I'm going to use grams this time just because that's what's given in my question, over grams of solution. But if you were to use a different value, you just have to make sure, or a different unit, you just have to make sure both the solute and the solution have the same unit of mass, times 10 to the power of 6. So let's first convert 60 kilograms into grams. So 60 kilograms, remember our unit conversion in 1 kilogram. I know that 1 kilogram equals 1,000 grams. And because of this, my kilograms cancel out. I get 60,000 grams. So let's plug those numbers in. So 0.02 grams divided by 60,000 grams times 10 to the power of 6. And you can already tell 0.02 is a very, very small number and 60,000 is a very, very large number. So if we weren't using ppm, you'd get a very, very small number. That's why we use this 10 to the power of 6 to make it into a number that we can use. So 0.02 divided by 60,000 times 10 to the power of 6 will give me 0.3 ppm. All right, now we're going to look at this exact same problem, but they want us to express it as ppb. Oops, that's not changed, but there. So if we were to try and express this same ratio as ppb, we would just use the parts per billion formula. So the parts per billion formula tells us grams of solute. Again, I just want to be consistent with my units, which is why I'm using grams of solution times 10 to the power of 9. So my grams of solute is 0.02 grams divided by, as I saw in the previous question, 60 kilograms is equal to 60,000 grams times 10 to the power of 9. So 0.02 divided by 60,000 times 10 to the power of 9 will give me 333 parts per billion. But just to be consistent with my significant digits, I've got one significant digit in my question, so I would round that out to 300 parts per billion. There we go. That's how you would express very small concentrations.